Observations of distant galaxies and quasars show that these objects are redshifted. The light emitted from them has been shifted to longer wavelengths. This can be seen by taking a frequency spectrum of an object and matching the spectroscopic pattern of emission or absorption lines corresponding to atoms of the chemical elements interacting with the light. These redshifts are uniformly isotropic, distributed evenly among the observed objects in all directions. If the redshift is interpreted as a Doppler shift, the recessional velocity of the object can be calculated. For some galaxies, it is possible to estimate distances via the cosmic distance ladder, when the recessional velocities are plotted against these distances. A linear relationship known as Hubble's law is observed. Quote, V equals h 0 d display style v equals h underscore 0 d, where v display style v is the recessional velocity of the galaxy or other distant object. D display style d is the proper distance to the object, and h 0 display style h underscore 0 is Hubble's constant, measured to be 4 plus 1, 3 minus 1, 4 kilometers per second, mpc by the WMAP. Hubble's law has two possible explanations. Either we are at the center of an explosion of galaxies, which is untenable under the assumption of the Copernican principle, or the universe is uniformly expanding everywhere. This universal expansion was predicted from general relativity by Friedmann in 1922 and Lemaître in 1927, well before Hubble made his 1929 analysis and observations. And it remains the cornerstone of the Big Bang model as developed by Friedmann, Lemaître, Robertson, and Walker. Quote, the theory requires the relation V equals h d display style v equals hd to hold at all times, where d display style d is the proper distance, v is the recessional velocity, and v display style v h display style h and d display style d vary as the universe expands. Hence we write h 0 display style h underscore 0 to denote the present day Hubble constant for distances much smaller than the size of the observable universe. The Hubble redshift can be thought of as the Doppler shift corresponding to the recession velocity v display style v. Quote, however, the redshift is not a true Doppler shift, but rather the result of the expansion of the universe between the time the light was emitted and the time that it was detected. That space is undergoing metric expansion is shown by direct observational evidence of the cosmological principle and the Copernican principle, which together with Hubble's law have no other explanation. Astronomical redshifts are extremely isotropic and homogeneous, supporting the cosmological principle that the universe looks the same in all directions. Along with much other evidence, if the redshifts were the result of an explosion from a center distant from us, they would not be so similar in different directions. Quote, measurements of the effects of the cosmic microwave background radiation on the dynamics of distant astrophysical systems in 2000 proved the Copernican principle, that, on a cosmological scale, the Earth is not in a central position. Radiation from the Big Bang was demonstrably warmer at earlier times throughout the universe. Uniform cooling of the CMB over billions of years is explainable only if the universe is experiencing a metric expansion, and excludes the possibility that we are near the unique center of an explosion. An unexplained discrepancy with the determination of the Hubble constant is known as Hubble tension. Techniques based on observation of the CMB suggest a lower value of this constant compared to the quantity derived from measurements based on the cosmic distance ladder.